So we're going to try to structure our thinking using a Venn diagram. So now we don't actually have specific outcomes we throw into the Venn diagram. It's a more generic way of just thinking about the events and the way they might intersect or the way they might happen together. So here inside this first circle here are the outcomes where I'm late for work, because we're thinking of going to work many, many days, and then these of the many, many days, this would be the ones where I'm late to work, and these would be the ones where I'm late returning, and these would be all the days together. Sometimes I'm not late at all, and sometimes I'm late both times. So here's how that looks. Both is here, where the two overlap, and we have the probability of A and B is 0.05. That's what we said. We said the probability A is 0.1, the probability of B was 0.2. Here's neither, not late at all. It's this piece outside here. I don't have any information about it, but we can get information to fill in those probabilities like this. So the probability of being an outcome overall is 1, and then we've got this disjoint, some formula for disjoint events. Probability A or B is probability A plus probability B if A and B are disjoint. So we can look at the Venn diagram, we can see disjointness. So things that are cut like this with no overlaps, like this piece and this piece, without counting this one, they don't have an overlap, so they don't share any outcomes. Or A and A complement don't share outcomes. So we can use those ideas to help us figure out probabilities. And the first thing we're going to do is we're going to take A here and break it into two pieces. The first piece is this one here. So that's A and B. I don't know how to write it. Maybe it's A and B. I got it here. And we're going to start filling in probabilities. So I'm going to put 0.05 into that slice, because those are the outcomes where A happens and B happens. I'm late both coming and going. And it happens 5% of the time. And now we've got this remaining piece here. This is A, but not B. Late for work, but not late going home. So that's late in the morning, but not in the evening. Like that. So I don't know what that is. I know being late in the morning is 0.1 overall. So the whole probability in here is 0.1. And these two, late in the morning and not evening, late in the morning and late in the evening, those are disjoint events. So their probability should add up to be the probability of them both of one or the other happening, which is 0.1. So I'm going to put 0.05 in here. So the sum of those two is 0.1. Now we could do the same thinking with B. Here's B. Part of the way B can happen, this is late coming home, is you're also late coming into work. And here are the places where you're late coming home, but you weren't late coming into work. Those two are disjoint events. The probability should sum to the probability of B. Probability of B overall was 0.2, so this plus that number, that's probability, should be that. So this will be 0.15. So basically we can get away with that. So this is late evening, not late in the morning. That's the probability of that is 0.15. And then now we filled in almost all the regions in the Venn diagram except this one out here. This one says never late at all. The sum of all the probabilities have to be 1. This is the only one left. So here I've got 0.25, 0.05, 0.05, 0.15. That's 0.1 plus 0.15, 0.25. So this is the rest. It has to be 0.75. This is just not late either time. So the chance of not being late morning or evening is 0.75. Once I've got the Venn diagram filled out, I can then answer any question you have about how the being late in the morning and late in the evening probabilities fit together. So here are some. Not late for work. Late for work is 0.1, that's this one. Not late for work is everything else, these two together. And we know there's a complement rule, so that's 0.9. 0.9. We could write that 1 minus the probability of A. Or you could look here and see, here are the ways you're not late for work, these two. And they add up to be 0.9. Not late, both morning and evening. Not late either. We got that, 0.75. And late morning or late in the evening. So here, that one would be just late one way or the other or both. That's these three together. That's 0.25. And we can check that that's the same as we might expect. Probability A plus probability of B minus the probability of A and B. You can just see it up there. It's going to happen. That's 0.1 plus 0.2 minus 0.05. And that's 0.25, yeah. Check. So that's our general sum rule. That if you want the probability of A or B, you take the probability of A plus the probability of B and subtract off the probability of A and B. That's our general sum rule. All right, so we survived another slide. This Venn diagram way of thinking about things can keep us from making mistakes. The most popular mistake that gets made is people want to put 0.1 right here and 0.2 right here and leave the 0.05 there. But then when you look at A by itself, it's 0.1 plus 0.05, that's the wrong answer. When you look at B by itself, it's 0.2 plus 0.05, that's the wrong answer. So you have to be careful when you see these probabilities separately, and A and B have been divided into two groups, or into two subsets, that the probabilities for these disjoint events that correspond to the pieces of A and the pieces of B have to add together to be the total probability of A and the total probability of B. And that makes, once I know one piece, I can figure out the other piece because they have to sum to be the thing I already know. Once I know that these two have to sum to be the thing I already know. That is helpful. And then if you're asked questions about things that you might care about, if you can identify the regions, there's only 4 pieces to this puzzle that correspond to the thing you want. You can just add the probabilities of the pieces that you want. So you could say, what's the probability I'm only late either morning or evening, but not both? That'd be morning, not evening, or evening, not morning. And those are disjoint. So these two probabilities add together to give 0.2. So you can answer just about any question you want. Any probability question involving the two events can be answered once you fill in the Venn diagram. Okay, so we're going to look at another application of independence in a minute. That's getting us ready for the next section that comes after this, and that's coming up on the next slide.